Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello and welcome to IT Pro TV. You're watching the CompTIA IT Fundamentals Show. I'm your host, Ronnie Wong, and today we'll be taking a look at, basic networking concepts. And here, of course, to help us to understand that mysterious world of networking better is going to be, the mystery man himself, Mr. Don Pezet. Don, welcome to the show.
Hey, thanks for having me, Ronnie. And, it's going to be a fun show because we're going to talk about computer networking. And if you are a older viewer, you probably remember a time when computers weren't networked, where networks were a completely optional thing that we didn't have to have, and there was all sorts of choice. It is not like that anymore. Networks are practically a guaranteed element of any computer system. In fact, when I sit down at a computer and find out that it's not networked, I look at it and say, well, what am I supposed to do with this thing, right? We have pretty much entered a stage in our civilization where we expect to have internet access, or at a minimum, the ability to rapidly share data between one system and another. And having multiple computers is also a commonplace thing. So computer networks are super important. What a lot of people don't realize is there is a lot of technology that goes behind building those networks, and it's an entire career field that you can make that your specialization and say, I want to be a network administrator. And for me personally, I know you feel the same way, Ronnie, it's a very rewarding career because unlike computers, where, you would think a computer deals in ones and zeros, things would either work or they wouldn't work, right? But Microsoft has proven with Windows that sometimes things sort of work. And there's like in-between area, in between a 1 and a 0. Well, in the networking world, it's actually very stable, very reliable. You can build network infrastructure, put it in place, and it'll run for years without failure. And I've always found that really rewarding work. So it is a neat career field. If you've never dealt with networking, though, you're in the right place, because we're going to take a look at some of the basic concepts that go on behind the scenes to create a network, to allow it to function, and help you determine whether or not computer networking is going to be an area that you'd like to specialize in the future.
All right, so Don, when I was first learning about networking, one of the first things that people told me is networks are just computers talking to one another. So Don, how does that concept fit in? Because I know I didn't really have to learn how to talk so much as I listened, and all of a sudden I was able to talk. But in computers, though, they don't tend to be able to just communicate on their own.
Right, and comparing it to human language is actually a really good example. So you speak English, I speak English, right? So the first time I met you, which I'm trying to remember, it was many years ago. I can't remember the first time I met you, but it's not like somebody had to come to me and say, Don, let me teach you how to talk to Ronnie, right? I just walked up to you and talked, right? But it's not always like that. And if you think about if you were to go and meet the president or a military general, somebody might come to you and say, all right, here's how you need to speak to His Royal Highness or whatever, right?
Protocols that exist.
If you were going to meet the Queen of England, there's a protocol that you follow, and somebody might have to teach you that. Now, when I was a kid, my parents taught me manners, and so when I talk to people, I might follow a certain protocol because of that. Some people didn't get taught manners, and they might not follow that. You might be from different regions, you have different dialects. Computers are the same way. Sometimes computers speak completely different languages, and you need a translator. You need somebody to sit in between. It used to be like that with Apple computers and Microsoft Windows computers. That Windows was running a protocol called NetBEUI, Macs were running a protocol called AppleTalk. They didn't work together, right? And you have to have a translator in between to let them communicate. Well, in today's world, we're kind of fortunate in that almost every computer speaks the same language, a language called TCP/IP, which is the Transmission Control Protocol, Internet Protocol. Don't worry about the details on it. It is so ubiquitous that pretty much every system these days runs TCP/IP. If it doesn't run TCP/IP, the odds are it's not connected to a network. That's become the standard. It's a standard protocol for the internet. And as a result, if you have a Mac, if you have a Windows machine, if you have an Android cell phone, an iOS phone, all of these devices, they can jump on a network and they can talk to each other. All right. Now that structure, that ability to talk to each other, that's not just something that's guessed at, right? There is some teaching. We learn to speak whatever our native language is from our parents. Well, these computers learn to speak from their parents, from the engineers that designed them. And those engineers all followed a standard model. And this is supposed to be a basic networking concept show, so I don't want to freak people out with crazy technical details, but all computer networking follows a standard model. It's called the OSI model, the Open Standards Interconnect model. And I've got it diagrammed here on my computer. This is a diagram I whipped up a few years back to help kind of illustrate how this model works. It's a 7-layer model. And when you send data from your computer, so let's say I send Ronnie an email, okay? I'm starting way up here at layer 7 when I write that email. And then the email goes down all these layers to the very bottom, which maps to like the physical cable, gets sent over to Ronnie's computer. And at Ronnie's computer, it starts down here at the bottom, and it goes back up to the top to where he can read the email. So when I sent that email, not only did I pass through the OSI model, I passed through it twice. I went down the model on the way out to Ronnie, and at Ronnie's end, it went back up the model. And if he replies to me, it bounces back to that model again. But this model creates a structured way for two systems to talk to each other. And when I say two systems, I mean laptops, phones, routers, switches, firewalls, access points, ATM machines, cash registers, refrigerators these days, the scale in my bathroom. They all communicate using networking now, and they all follow this model. This model breaks up the communication into pieces that can be made to be compatible. If Microsoft wants to do something totally different than Apple, that's fine. They can do that as long as they do it up here at the top layers. As long as the bottom layers are the same, Microsoft will be able to talk to Apple no problem, right? Then it usually starts around layer 4, so layers 1 through 4. As long as those are the same, two computers will be able to talk to each other. And if you look over on the side, I think my head covers some of it up, but at layer 3 and layer 4, that's where we have TCP and IP. I mentioned TCP/IP is a standard used by darn near every machine out there. So if you become a network engineer, you'll find the bulk of your time is spent on these bottom 4 layers. There's 7 layers altogether, but those 4 are where you'll spend most of your time doing your work. If you're a developer or a system admin, the bulk of your time is spent up here in layers 5 through 7. It creates a divide. And the divide is so well defined that when you go to a lot of IT departments, they'll have a system administrator team and a network administrator team. They'll have a separate networking team. If it's a large company, if it's a small company, or maybe in a medium, they might blend roles, but larger organizations will have a dedicated networking team that is focused just on layer 1 through 4. And the cool thing about networking, or what I always thought was cool, was I didn't care if you used a Mac or Windows. And somebody would say, oh, I like Google Chrome. I hate Internet Explorer. Or Firefox is the best browser. Or Mac OS is way better. I only run Ubuntu Linux. I don't care. You all use TCP/IP, and I make sure that gets from point A to point B, right? That's a rewarding thing to be able to do. So this model plays into all communications. But we don't really see it that way. As an end user, we see something much different. We see something like this, right? I've kind of charted out a home, and I've charted it out in a way that shows every device that's involved with getting your computer onto the internet. When you browse to the internet, your computer doesn't just go straight out to the internet. It communicates through a series of equipment. And it might be completely broken out like I've got it here in the diagram. But in today's world, we usually have something much more simple, right? Back in the old days, and when I said, I mean like 1980, 1990, not a long time ago, right? But back in the 1980s, 1990s, you would have separate equipment for all of this stuff. And some of it you wouldn't even have, like wireless didn't exist back then. But you would have separate pieces of equipment. Technology has advanced so far that we have small devices that are able to perform a lot of these roles. So for example, your home might actually look like this, where you have laptops and PCs and cell phones and TVs that all just connect to a device that is a router, wireless access point, switch, and firewall all wrapped into one. And in fact, in the next episode, we're going to show how to configure a wireless router, and we'll run through the process of setting up one of these devices that does all of that wrapped into one. But that one device, it's just really talented. It is actually performing the role of 4 different devices. And so in my first diagram here, I'm showing all of those devices kind of separately. And each one plays a different role in your communication, right? Each one is providing a different function or feature to let your network do its job. And if you become a network engineer, one of the things you have to do is design networks like this so that they operate efficiently and reliably, that communications are always able to get from point A to point B the way that you expect. So that's something we have to be aware of as we design a network, that the OSI model's back there, the complex protocols are back there, all this crazy engineering stuff is back there. But at the end of the day, it's really like a highway system. It's a series of roads, and if you've seen one road, you've seen them all. It's just knowing which one is the right one to take. So we're building pathways through our network to be able to connect one computer to another computer, or to connect one computer out to the internet, which is like connecting one computer to millions of computers. It's really all done the same way. That's a basic tenet of networking.
All right, Don, when we start to do something like this and we get it set up, these devices also normally have to be somehow uniquely identified, don't they? So how is that done? So like you and I have names, but on computers, do they have names?
All right, so not only do they have names, they have like multiple names. It can be confusing at times. And going back to that OSI model, there's different names that come into play at different layers. So when computers talk to each other, there's all sorts of different things that can be happening to allow them to find each other. And it all depends on where the other computer happens to be. So for example, if we take that house, right? Down here, I have two computers that are plugged into a common switch, right? This is a pretty common thing. I've got a couple of computers, they've got a physical cable that runs into a switch, right? Or maybe it's a laptop and it's wireless going to an access point that's also plugged into the switch. Wireless versus wired, that's at that first layer of the OSI model. After that, the rest of the model is all the same, so they don't even see the difference. When that laptop talks to a PC, they just talk to each other like they're directly connected. They don't even think about the fact that one of them is wireless. But because they're in the same home, right? Think about it's dinner time, right? Dinner is done, it's on the table, and you're ready for the family to come sit down and eat, right? If everybody's right there in the house with you, what do? You just yell out, "Hey, everybody, dinner time," right? And everybody comes down to the table and they eat. That's, in networking, we call that a broadcast. You're sending one message out to everybody who can hear it. Well, who can hear it? The people in your house. Your neighbor can't hear that, or hopefully. Some of these new houses these days are like wall to wall, or if you're in an apartment, maybe your neighbors can. But somebody across the street can't hear that. Somebody in the next city over can't hear that. Somebody in another country can't hear that. It's just the people in your home, right? Well, when you have computers plugged into a switch, that's their home. It's called a local area network, or a LAN. And that LAN, that's their home. And they can talk to each other just by yelling. It's not the most efficient, right? But it works. So if I'm on this computer down here, and I want to talk to Ronnie in this other computer, I can just yell out, and I can say, "Hey, is anybody named Ronnie out there?"
Oh yeah, I'm Ronnie.
And Ronnie hears that. He hears it because he's right here next to me, right? He hears it and he responds. Now, let's say you, the viewer, I don't know you personally, so let's just say your name is Bob, right? So, and if your name is Bob, good job, this works. And so I yell, "Hey, anybody out there named Bob?" Well, if you were here in the building, you'd hear me say that, right? And so you could just say, yeah, my name's Bob. And now we could have a conversation. But you're remote. Now, you might hear me because I'm being thrown into this video, but if you're yelling at your TV right now, "It's me, it's Bob, Dom, why are you talking to me?" I can't hear, it's not coming back, right? That type of communication doesn't work. But for computers on the same LAN, it does. They just yell out. They yell out and they do it all the time, right? Let me show you. If I jump over to my Windows machine here, and I were to browse the hard drive on this thing, or if I browse the hard drive, I'm browsing my own local files. But in Windows, I can choose to browse the network, right? And, oh, I've got my network discovery turned off. Let me just turn that on real quick. And I can browse the network, and it's going to start looking across the network to try and find other machines, okay? And there it goes. It just found a bunch of stuff. It found a computer called Storage01. It found Nate's VM QNAP, PC, VMware host. It found a bunch of televisions, right? It did a shout out there and said, "Hey, is anybody out there? I'm lonely." And all of these devices replied back and said, "Yeah, we're out here," right? This guy right here, this is a Sonos speaker that's in Tim's office. So if we wanted to mess with that, throw some music at it, we could talk over the network. It's on the same network as my laptop, right? I'm talking. And it's really complex on the back end. On the back end, I sent out what was called an ARP request, an Address Resolution Protocol request, a broadcast that goes out. And I said, "Is anybody out there? And if you are, can you tell me your address, your name," right? The name that's being used is something really weird. It's what's called a Media Access Control address, or MAC. I said a MAC address a moment ago, and some people think I mean Mac like an Apple Macintosh. It's Media Access Control. Apple Macs do have MAC addresses. Windows machines have MAC addresses. Linux machines have MAC addresses. Remember that OSI model is shared by all of them. They all have the same kind of idea. So it's called a MAC address. And here's the collection of MAC addresses that my Windows machine has seen. There's a lot of them here, right? Now, when I was looking in this window back here, there weren't, I was about to say there weren't that many devices, but man, there sure are, aren't there? There's a lot of devices on our network. We're an IT company. We have a lot of gadgets, apparently. Here's Don's office, and Don's office left. Those are 2 TVs that are in my office. So so I can spot those. Don's Fire TV. I don't have a Fire TV.
Well, there you go.
Do we have another employee named Don? See, this is how we discover and we learn, right? So the computer's discovering and finding. And when it talks to each of them, it's making a list, this list that I've got in the background here, and saying, here's the people that I've met. And if I want to talk to them, this is the address I can use to talk. And so when we communicate, that computer will send a message out. It'll send the message to a switch or a hub or some other device, a wireless access point. And that device will send it on to the right machine at the other end. And that machine will receive the communication and then reply back, right? This is all happening at this layer 1, layer 2 type area in the OSI model. They're communicating back and forth using these simple addresses. And oftentimes, you don't even have to configure it. This is just working by default. On my Windows machine, what did I have to do? I didn't have to configure the network. I just had to tell Windows, yeah, I want to share stuff on my network. And the moment I said that, all the devices showed up. And now I can reach out. Now, there's still things like authentication and security and all that on top of it, but I see the devices now, and I can start to talk to them. And I'm on a Windows machine, but I can guarantee you many of these devices aren't running Windows. I mean, down here at the bottom, there's printers. Those printers aren't running Windows, Linux, or Mac. They're running proprietary operating systems that are powering those printers. Some of these up here, I know are Macs. Some of them I know are Windows. Nate, I know that his virtual machine that he has is a Windows machine. And some of these other ones, I have no idea what they are. Like that looks like a serial number to me. So I'm not quite sure what that one is. But those devices, they're out there, we're communicating, and this is a basic example of simple in-house communications. A network just needs a device like a hub or a switch to interconnect these devices so they can communicate. And then TCP/IP or other protocols kick in to allow those devices to exchange information. The hardest part here is just plugging in the cables, right? If your home is not pre-wired, trying to run cables through a wall can actually be a bit of a struggle. If they're all in the same room, you can just stick a switch right there and plug the computers in and you're in business. And that's where access points really come in handy, is if your building isn't wired, you can set up a wireless access point. And your laptops, your cell phones, they can jump on it without cabling, and now they can communicate on the network as well, and you'll see and communicate with them too. So that's really a basic aspect of what's called a local communication. The MAC address, the Media Access Control address, that's what powers this. And if we go back to my OSI model diagram, you'll see where I've got down here at layer 2, this data link layer, there's a little box here that says MAC. And that's the Media Access Control address that lets us move data between 2 computers on the same network.
All right, Don, so helping us understand this idea of the local area network and that home network, but you also had those other devices, and if I now need to communicate outside network and I can't use the MAC address, well, how am I going to do this?
All right, so that's where things get more complex, all right? MAC addresses, we can use those to communicate if we're on the same network. So if I shout out and I say, hey, is anybody named Ronnie?
Well, Ronnie, yeah,
Ronnie hears me, right? He replies back, we've got it. But what if Ronnie's at home? So if he's at home, Ronnie lives a long, long way away from here. So about an hour away, right? So if I'm standing right here at this podium, and maybe we're not streaming on the internet or anything like that, and I just say, hey, anybody other named Ronnie? I'm not going to hear anything. Meanwhile, he's sitting at home, got his feet up on the table, just relaxing, has no idea that I'm trying to find him, right? So computers have to have a way to find people that are far away, right? And that's where things start to get a little more complex, because your average computer can't do it. That on the internet, we'll use the internet as an example because that's normally what we're talking about, right? On the internet, there are millions of computers spread all around the globe. Your computer can't know all of them. and broadcasts don't work. Imagine if I sent a broadcast out to the entire world, right? I'm just trying to find Ronnie who's maybe an hour away, and I'm going to send a message to everyone on the planet. Hey, is anybody named Ronnie? Well, let's assume that worked.
Yeah.
Right? How many Ronnies are in the planet?
A lot.
There'd be a lot of confusion. We have to have a way to tell those people apart. We have to have a way to communicate efficiently, and we can't broadcast. Broadcasts are not allowed on the internet. If you send a broadcast out, your ISP, whoever your internet service provider is, just deletes it. They don't forward it along. On the internet, we use what are called unicasts. A unicast is a message sent from one machine to one other machine, a one-to-one communication. On a local network, you'll normally start with a broadcast. You'll broadcast to find somebody, and once you've found them, then you switch to a unicast, and now you're unicasting back and forth. But on the internet, it's got to be unicast from the very beginning, because you just can't send a broadcast out there on the internet. And that's a problem, because I can't just reach out to the world and say, hey, I'm looking for somebody named Ronnie. That doesn't work, right? So first off, I have to know somebody's remote, and second, I have to have a way to get there. So how do I know they're remote? Well, MAC addresses, media access control addresses, those are automatic. They're burned into your computer. They're assigned at the factory. So you don't configure them. They're just done. They're there. But there's another type of address that's up here at the layer 3 of the OSI model called a network address. And if you're using TCP/IP, which all of us are, that network address is called an IP address. IP stands for Internet Protocol address. And that Internet Protocol address tells you who's on your network and who's somewhere else in the world, right? When I look at my Windows machine, I'll go back to that command prompt, and I'm going to just run a little command called ipconfig. Don't worry so much about the command. But when I look at it, I can see I have an IPv4 address right here. Mine is 10.0.13.24. All right. Now, Ronnie, do you know the IP address of your laptop? Ronnie's going to look up his address. That address right there is the IPv4 address for my laptop. And I've got a subnet mask right here. The subnet mask tells me, or gives me a hint, as to who's on the same network as me and who's remote. When I look at this subnet mask, see how there's a 255 and then a 255 and then a 0 and a 0. The 255s, that's telling me which of these numbers identifies my network. And the zeros tell me who identifies people on my network, right? So my network, where it's got 255, 255, my network is 10.0, okay? Anybody whose address starts with 10.0 is on the same network as me. The rest of it, 13.24, that's just my laptop. Nobody else will use that same one because otherwise they'd bump into me, right? So that's going to be the host. Well, Ronnie looked, and what's your IP?
It is 10.0.13.228.
228, all right. So 10.0.13.228. His 13.228, that doesn't match mine, but that's good. So we don't want those to match. We'd bump into each other. But his does start with 10.0. His laptop is on the same network as my laptop. We can talk to each other. And it was this subnet mask that helped me figure that out, right? What if it wasn't the same? What if Ronnie said, oh yeah, my address is 209.151.13.228. Well, 209.251 is different than 10.0. We're not on the same network. I can use that address to figure out Ronnie's not on the network as me. So I don't know how to get to him. So if I want to get to Ronnie, I'm going to need some help. And that help comes in the form of a device called a router. If I go back to my diagram, we've been talking about local communications, which occur through a switch or through an access point. But a router is a device that connects more than one network together. It connects your local area network with another network. Now, in an enterprise, in a big business, you might have several LANs. So it might be connecting multiple LANs. But in a home environment, like in my diagram, that other network is usually the internet. That router is connecting us to the internet. And that internet, it is a whole collection of thousands of LANs that have all been joined together. And when you do that, it's not called a LAN anymore. It's called a WAN. It's called a wide area network. A wide area network covers a wide geographic area. In the case of the internet, it's the entire planet. It covers the whole globe. And when I want to communicate out of there, I need a roadmap, right? If you just got on the interstate system or got on the highway and thought you could drive to a city 1,000 miles away, odds are you're going to get lost along the way. You need a map. And if you have an atlas or Google Maps or Waze, definitely not Apple Maps, but if you have some kind of mapping program, then you'll find your way there, right? That's what routers are. Routers are like navigators. When I go to that router and I say, look, I'm trying to get to Ronnie, his address is totally different than mine. I don't know how to get there. The router says, hey, no problem. No problem. I'll get you there. And I send my data to the router, and the router figures out the best way to send the data along. Now, if I'm talking to somebody local, I don't need the router at all. I can ignore the router. I can just talk directly to that person. But anything remote, that traffic's going to go through the router, and the router will send it out to the internet. And this stuff happens all the time, and we don't even see that, right? It's kind of invisible. So for example, if I go to my Windows machine and I fire up a web browser, and I'm going to go to, let's just go to CNN.com, all right? So I'm going to CNN.com. Eventually, I'm going to CNN.com. I will get there. And once I'm there, I'm pulling up their page. Now, believe it or not, CNN does not keep their servers here in the building at IT Pro TV. So their servers are somewhere else. I don't even know where. I have no idea. They might be in Atlanta. That's where CNN's based out of. But they're a big organization. So their servers are probably all over the planet. I have no idea where I went, but somehow I got there, right? The router figured out how to get there, and it did it for me. That's all invisible. That's the glory of networking. When networks work properly, you don't even know they're there. You don't even see it happen. I'm just magically talking to CNN. In reality, I went through at least 5 different routers to get to CNN, each router helping each other out to get me all the way over there. And if we take a look at that process, we can actually see it. Let's see here. That was, I just went to CNN.com, right? So I'm using a little utility called Traceroute. And what Traceroute does is it takes a look at the path that you followed to get to some destination. And so here it's going, and I can see that I left our building and I moved over to our internet service provider. Our service provider is called GRU, the Gainesville Regional Utilities. They sent me to some node that has no name, right? And then I was sent over to NTT, which is a big telecom in Atlanta, Georgia. I got sent to Atlanta, Georgia. And then I got sent to CNN. I just guessed 5 earlier. I lucked out. So I hit 5 routers. I passed through 5 different, well, actually I didn't pass through 5. I passed through 4 different routers. This last one is the actual server that I was communicating with. So I passed through 4 routers. 4 routers helped me figure out where I was getting to. Sometimes you might pass through a lot more. Let's see, what would be a good example of that? Let's say I'm going to somewhere that's in England, right? I've got to jump overseas to get to a foreign website, or maybe one in Russia, right? So if I did a trace route to, we'll do pravda.ru. It's like a tabloid or whatever. Russia is the first thing that popped into my mind. So when I'm reaching out to them, their servers aren't going to be here in the U.S. Well, probably not. So I'm going to get routed over, and actually I can see I jumped over to France right there. So I'm getting sent over cross-continental. You can always spot when you go cross-continental, because see how these times jumped up? I was at 13 milliseconds, and then I jumped to 111 milliseconds, right? That's a big jump. And now I jumped up to 200 milliseconds. And that's usually because we're doing a transatlantic cable. Like I went under the ocean for a while to get over there. I had to pass through 7 different routers to get to Pravda, right? So a big jump to get there. Sometimes it can be 11, 15 routers, right? But in today's day and age where everybody's doing cloud deployments, you're usually much closer to where you're trying to get. But these are all routers that are working together to help you get to a destination. And in your own home, you would have a router or a small office, big office enterprise. And that is the first leg in that journey. That router says, you're coming from one network, you're going to a different network, let me help you get there. I'm going to help steer you along. Now the router, it doesn't know how to get to Russia either, right? But it knows the next router in line, which is your service provider. And your service provider does know how to get to Russia. And so it then goes to the next router to finally get you over there. And now you're talking to that server. And I'm just using Russia as an example, right? It could be just talking to Google or Microsoft, France, whoever. This process is the same. That's really the cool part about networking is for the most part, it's language independent, politics independent, religion independent. It's just, look, we're going to get you from point A to point B. We don't care what you're doing. We're just going to make it happen. We're going to get you there. And that's kind of a rewarding part I find with networking. But that's basically that next stage when we communicate remotely. Now, there's a little more to it that I want to highlight. Like, I keep showing you these IP addresses on the screen. For some of you, this might be the first time you've seen an IP address because we normally hide those with names. And I want to talk about that process a little bit more. And there's some more just on how these communications occur. But Ronnie's giving me the out of time signal over here. So why don't we break this into a two-parter? And in the next episode, we'll pick back up. I want to talk more about those remote communications. I want to talk about names, how names work attached to IP addresses, and how we hide all this from our users and see that functionality, as well as delve a little bit more into how we actually transmit that data, which is pretty neat stuff.
All right, Don. Well, thank you for helping us to understand this concept a bit more. If we haven't seen any networking technology at all, at least we understand the concept of communication, how that's beginning to work, especially between the computers inside of a network, and even on the basics of us extending outside of our own network as well. But that's going to do it for this episode then. Signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Don Pizzette.
Stay tuned right here for more of your CompTIA IT Fundamental Show.
Thank you for watching IT Pro TV.